Okay, so let's discuss projects uh, and what you can do for Physics 131. Okay, so as you know, the project is a big part of your accomplishments or the things that are required in here in the course Physics 131 or Computational Physics. And the idea of having a project is for you to be able to apply concepts you learned in class to physical situations. You should also show knowledge and acquired skills in programming and also to demonstrate analytical skills by analyzing results of your simulations. Okay, so I'd like to show before we move on to what projects you can do, I'd like to show you a few of the projects that former Physics 131 students have already done. And you can actually work around these projects or work to improve these projects. I will show you the projects that were done and I can describe to you what the work that still needs to be done or that can still be further done in order to improve the work and make it a little bit more, let's say, realistic. Okay, so let's first begin with the Ripple Tank simulator. Okay, so one of your former upper class mates, okay, decided to do a Ripple Tank simulator. So in this part of the video, you'll see the image. Of course, I'm not going to show to you the code that she wrote, so I'm just going to show to you the image. So this is the Ripple Tank simulator that she was able to do. Okay, as you can see here that the source point is in the middle. That means that the trigger for the waves is somewhere here. But there are also 2 points here outside. Okay, so these are the interference of three source points, and it's quite interesting. But if you're going to simulate a ripple tank, what you can do is actually to use 1 or 2 points, and then you use interference to add those 2 points. Use some sort of a 3D plotting method, such as the surf command. And then you can discuss what happens to the wave if you had, for example, a barrier. If you had a barrier somewhere here, what happens to the wave? Or if you have a small slit, you can add some sort of barrier here with a small slit somewhere here. And then you can also discuss what happens to the waves. Or you can discuss what happens to the wave when the two source points are not in phase. So for example, if one source point is out of sync with this source point. So for example, if they are 180 degrees out of sync. So if this one goes up, this one goes down, and the result of the waves traveling and the interference of those waves, you can simulate using this, well, as a part of your, or as your project. Okay, so that's one example. Another example that has been done by your previous classmate is to do ray tracing, but he improved a little bit on that by using what is called a GUI or a graphical user interface. Okay, so I'm going to show to you first the his ray tracing project. Okay, so the idea here is to use optics, okay, or whatever lessons or whatever concepts learned in Physics 103 he was able to use here. So he simulated an object and tried to simulate what the image will look like using the rules of optics that he learned from Physics 103. He also improved on this um, project by using a graphical user interface. So in this case, he was able to develop this graphical user interface. Okay, so what we can do now here is to add a focal length. So for example, let's use a focal length of 2 units, an object distance of about 5 times the focal length, and an object height of about 5, let's say. And I'm just going to add a grid so that it becomes more apparent. And then I can find the image. So using this GUI that he was able to develop. So as you can see, the object has a height of 5 units. The object distance is about 10 units from the lens. And based on this, the image is seen to be somewhere here. Okay, so this is about, if this is 2 units, it's about 2.5 units maybe, and this is about 1.25 or 1.2, something like that, okay? So this is a GUI, but of course, it would be nice if you can put a slider here, a slider there, and a slider here so that people can just slide up or down and adjust the height, and then instantaneously the image here would also, or the whole image here would also change according to what the slider values are here. So that's also something that you can do. Of course, it doesn't have to be a ray tracing. It can also be something else, like for example projectile motion. If you include air resistance and you use a slider to increase the air resistance, or the slider to change the shape of the object, and so on and so forth. What will, I mean, you can simulate what will happen to the trajectory of the object. Okay, so that's one project that you can do, or one of the projects that has been done as well. You can also try to improve on this, simulating walking or running. So let's show this first. Okay, so one of your classmates or one of your upper batchmates actually tried to simulate walking using a double pendulum. So you used a pair of double pendulums, one for the right foot and one for the left, one for the right leg and one for the left leg. Okay, so you can see that it's, well, it's almost the same as walking, but the angles are not so accurate. Secondly, the walk is kind of slow. Okay, so he probably used a smaller time scale, so you can use to make this go faster. You can use a larger time interval. Okay. Of course, some improvement here would be to add appendages, such as, for example, a foot. So you'll have a triple pendulum. Okay, and then you can also compare this to videos of walking. So you compare this side by side as a subplot, for example. You have this as a subplot 1 and the other video as a subplot 2, and then compare how the simulation of walking is fares with the actual person walking. Okay, so that's one thing that you can do. You can also do simulation of running, okay, as one of your upper classmates have done. So let me just arrange things here a bit. Wait a second. Okay, so running, here is the simulation that one of your upper batchmates has done to simulate running. Okay, so you can see here that he simulated quite well, but it doesn't seem that his leg is not so extended. It should be a little bit extended more. The shin should be extended a little bit more. The lower leg, I mean, should be extended a little bit more. But there's also a problem with the using a double pendulum without any correction, as you will see later on. Okay, so what happened? Okay, as you will see later on, this knee here is going to be bent like this. It'll be bent in the opposite direction, and that's part of the error that accumulates as the double pendulum swings. So let's see if we're able to. Let's take a look if we're able to see that. Okay, so now you see that the leg is already becoming straight. So you see here now it's quite straight, that almost straight. And here, if you follow that, you'll see that it's, yeah, that it's straight. And if you wait a few more cycles, you'll see that it'll be bent. Yeah, now it's really straight, and it's starting to become unnatural. And okay, now you see that it's still straight, but in a few cycles you'll see that it'll bend unnaturally. Okay, like there, did you see it? Okay, so maybe one more cycle. Okay, so there. Okay, so you see that the lower leg has been bent forward more than the upper leg, which is a natural form. So this is something that needs to be improved. It's uncorrected. Yeah, now it's pretty obvious. It has to be the angle has to be constant all the time, and it has to be corrected every cycle in order to reduce this error in that accumulates over a certain number of cycles. Okay, so that's how what your class or your upper batchmates did to simulate walking or running. You can also do modeling. You can also model the shooting form of basketball. So if you like basketball, then you can also do that. Okay, so in this simulation, he used a three um, pendulum. So this is the arm, and this is what the arm's supposed to look like when you shoot a ball. Okay. Okay, so let's try to run that again. So this is your upper arm, the lower arm, and this is the hand. So that's the shooting hand, and you see the flick of the shooting hand as you're trying to trying to throw the ball towards the goal. Okay, so it's quite accurate, but it would be good if you can if it can be compared with an actual shooting hand and and if you can also describe the dynamics, what is happening here, what are the angles, and so on and so forth. Okay, so that's one project. You can also do weather tracking. Okay, so now I don't have the simulation for this because I mean I don't have the MATLAB file for this, and that's because uh, the student who did this actually did this project for for a couple of for about 1 month, I think, or a little bit more than 1 month, so about 4 or 5 weeks, because she needed to gather data. Okay, and this is the data that she gathered. This is, as you know, this is the picture of a weather disturbance near the Philippines or around the Philippines. Okay, and what she did was she used MATLAB to get these images every 30 minutes, because this image in the Pagasa website is generated every 30 minutes. So she had her program running for a few weeks, okay, especially if there are storms. So and every 30 minutes, her program goes to the website and downloads this picture. And then once she has downloaded the picture, she then uses the features in MATLAB that can extract certain features here in the storm, for example. You can do that in MATLAB, and this is what she was able to do. So she was able to pinpoint this certain feature, okay, here. And then she followed what is happening to that feature for each picture, and from there, she was able to track what is happening to that feature, which is essentially tracking the eye of the storm as it goes towards the Philippines. So once you are able to track this feature, she just used uh, interpolation or regression to be able to get the line that will be able to predict the trajectory of the thunderstorm. Okay, so you can do that as well, but if you're going to do that, I would really appreciate it if you can do it using machine learning. Okay, so that's what she did. Okay, so weather tracking, and also a couple of your upper batchmates were able to do face detection. Okay, so an upper batchmate did face detection using correlation, and one of your upper batchmates last year did his project on face detection using machine learning. Okay, so let's see. Okay, so let's try to run this first. Okay, waiting for input. Okay, now I have to put just a few images here. So if you just bear with me for a little while, because his program requires that I put in some image. Okay, so just a little bit more forward. Okay, image one, then image 10. Oh. Oh, okay, let me run this again. So image 1.jpg, image 7.6. Okay, and that's it. So just wait for the results right here. Okay, so let me just show you the results. Okay, so let's see now. Okay, so what his program requires is to get these six images. Okay, so it has these six images. Okay, and what his program does is to compare these six images together. Okay, so and the way to do that, the way he did that was to use a correlation function using Fourier transform. Okay, so for example, he compared between these two images. Now, even though we know that these two images aren't the same, this is an image of a man and this is an image of a woman, and using correlation, Fourier transform, he was able to say that the image is 86% accurate. Okay, and for this image, he was able to say that it was 84% accurate. This is also 84% accurate, so those are actually the same images. And this is about 7% accurate. This one, of course, is 100% accurate because these are two of the same images, and this is also 100% accurate. Okay, that's one project of face detection using correlation via FFT. You can also do face recognition using um, machine learning. Okay, and for this, okay, so what happened? I have to choose another image. Okay, let's see. Let's use this. Okay, so let's wait a bit and see what happens. Okay, so the idea here is I gave the program an image, and the program was able to identify whose face it belonged to. So this is one of the images was generated. Um, so he was able to use his program by studying, I think he studied the eyes here and compared it with other images that's all that he already generated before. So there are what you call test images. So, and they're also called they're also training images. So he gathered a lot of images, pictures of his classmates, and used those as training sets. And then he also used a part of them as test sets. And then what his program does is to get a new image, and depending on what the image gives out, then his program is able to detect which classmate of his is that image, okay, so to speak. Okay, so those are the projects that sample projects that I will describe to you. Here are also a few sample projects that you can do. This is sample projects for partial differential equation using partial differential equations. And you can use steady state distribution. For example, here you have to compute for the steady state distribution of the concentration of the tank. So this is the tank, and this is the differential equation. So you have to simulate what is happening or the distribution of the concentration here in the tank. Here you have two fluids with different densities, and you have to simulate what these fluids or how these fluids are moving relative to each other. Okay, I think this is an animation, so you have to animate the movement of these two plates. One plate is on top of the oil, and the other is at the bottom of the water. Okay, another problem here is this is a heat problem. So, oh, sorry, not a heat problem, but an electrostatic problem. So you just have to show the the potential and electric field distribution given this system. It doesn't have to be this system, of course. You can use a more relevant system or more relevant geometry. You can also solve this same system using numerical methods for the two-dimensional capacitors. So that's also electrostatic. And of course, you can do a string. You can simulate or animate the string. Okay, used by solving the this wave equation. Okay, so those are just some of the projects that you can do. You can, of course, um, make suggestions or look for projects. We can discuss. You can list down all your ideas, and then we can discuss which projects are feasible based on the amount of time that you have and the amount of resources that are available to you. Okay, so I hope that I've enlightened you a little bit about the project. Okay, and if there are any questions, just ask.